Hi guys, in this video we're going to look at more examples on basic integration, and let's see if we can just take you through on how I would work out some of these questions. If you have questions that you might want me to look at, let me know in the comment section, or you can send them to me via email or WhatsApp. So here I'm going to sample some questions from question 1. Let's see how you'd approach them. So if you have, let's say, something like question 1a there, where you have an exponent ex plus 1, and then over the root of x plus 1 with respect to x. So to integrate something like this, we're going to use substitution. So here, of course, through practice, you get to understand that this actually works for algebraic substitution. Why? You should be able to express this as the first part would be 1 over root x plus 1, and the second part would be the more like the parent expression, e to the root of x plus 1 dx. So you should be able to visualize this to say it actually is something like this. And if you can view it like that, then you should see that it actually does show up as a derivative of a function multiplying the same function, let's say e to the power f of x. And we know to say in this case, if you can view an exponent such that its coefficient is basically just the derivative of its argument, then in that case, substitution works. So again, the coefficient of the exponent function, if you can see that it somehow relates to the derivative of the argument of the exponent, then in that case, substitution will work. It's like how for trig expressions, if you can view that the coefficient of the trig expression is actually the derivative of the argument of the trig expression, then in that case, the algebraic substitution works as well. You'll see this coming up in B. And it actually shows up in B and also in C there. But for now, let's look at 1a and let's see how you'd work it out. So for 1a, here you'd let the argument of the exponent to be our u. So let u be equal to, together with the root there, x plus 1. So once you do this, get the derivative of the function with respect to x. Of course, here you'd have to express it as with the power half there. You know that the root simplifies to that. So when you differentiate, the 1 over 2 multiplies here. This remains the same. The power reduces by 1 to become minus half, like that. And when you change this back to a root and using indices, it reduces to 1 over, and then this will be 2 root x plus 1. So from here, make the x the subject of the formula. You notice that this becomes the x is equal to the 2 root x plus 1 comes here, multiplying du. Now we can do our substitution. So the integral, the first part is 1 over root x plus 1, so that will remain root x plus 1, multiplying e to the power root x plus 1. Remember, that is our definition of u, so that will be our u. In fact, this root x plus 1 as well, we can view it as our u, so we can put this to be our u there. And then we have our dx. For dx here, we see that dx reduced to be this, and this term here is u, so it will be 2, where we have root x plus 1, that is just u, and then we have du. Here we see that the u gets to cancel out, leaving us with only the integral of e to the power u du. And of course, the integral of e to the power u with respect to x, with respect to u, reduces to just e to the power u as well. So since we are doing this without limits, so this will be plus the integral of the constant of integration. And of course, when we bring back what u is, so here the solution becomes e to the power root x plus 1 plus that constant of integration. So that becomes our solution to this problem. Let's look at our second problem. Here, of course, we're going to look at b there. And in b, we have the integral of sine theta root of 7 minus 2. This is cos cos theta, and then d theta. So how would you work out this one? So just as I pointed out earlier, here we see that it does have that form I mentioned, to say that you get to see that the coefficient of the trig expression is actually the derivative of its argument. So not necessarily. So here, of course, it's not necessary for the trig part, but when it's similar anyway. But let's view it in this form. Let's view the root here as a power minus 2 cos theta d theta. Of course, here the root will end up as a power half there. So here we see that this expression, if we look at the argument there, or what is inside the brackets there, view it as f of x. So this is f of x raised to a power. Let's generalize it as power n. And then when you differentiate this, you see that what you get is actually the coefficient, or the expression that comes here. In this case, of course, we see that u substitution, or the algebraic substitution, gets to work. Here, of course, you would have to let u be equal to the expression that is raised to the power there. In this case, for our problem, u will have to be 7 to cos theta. So when you differentiate this with respect to theta this time, what you're going to have is minus 2. The derivative of 7 is 0, so just minus 2 there being a constant. Differentiate the cos, giving you minus sine theta. So the negative and negative will give positive, so you have du d theta is equals to 2 sine theta, implying that when you make d theta, not d theta subject to the formula, you have d theta being equals to du over 2 sine theta. So now we perform our substitution. We now have the integral of sine theta, where we have that expression in the brackets. That becomes u. We define the 7 minus 2 cos theta to be u. The power remains as half there. Where we have d theta, we now substitute what d theta is in terms of du. So it's going to be du over 2 sine theta. We see that the sine theta and the sine theta will cancel. It's always the goal of substitution here that once you perform the substitution, the old variable always disappears. You remain with only the new variable here being u. So this is now just the integral of u to the power half du, but there's this 2 in the denominator, so we can bring it out being a constant. It won't be affected by the integral. When we integrate this, we'll have 1 over 2. To the half, add 1 becomes 3 over 2 over 3 over 2. And plus that constant of integration. So here, of course, when you simplify, this 2 and this 2, of course, they're going to cancel out. So that now we remain with 1 over 3 u to the power 3 over 2 plus c. When we bring back what u is, u was defined to be 7 minus 2 cos theta. This becomes 1 over 3, and then 7 minus 2 cos theta to the power 3 over 2 plus c. So this becomes the solution to that expression. Let's see if we can squeeze in one more problem. And here we can do, I think we can do c and d as well. So we have the integral of e to the x sec squared e to the x dx. Here as well, we're seeing that the argument of the trig expression, this, when we differentiate it, we get the coefficient. So here, the algebraic substitution here works. So we'll let u be equals to e to the x, knowing that the derivative of u with respect to x will still be e to the x. So we make dx subject. This implies that dx will be du over e to the x. So that now when we perform our substitution, what you're going to have is the integral of u, since e to the x is u. So here this becomes u. And then we have sec squared u. And then where we have dx, we'll have du over, that's e to the x, that's basically u. This and this will cancel, leaving us with only the integral of sec squared u du. And we know to say the derivative of tan x is sec squared x, implying that the integral of sec squared x is equals to tan x. In the same way, the integral of sec squared u will have to be tan u. Since we're doing this without limits, plus c. Bringing back what u is, so this will be tan e to the x plus c. And we're done. Let's look at that last one there. Looks interesting, but not the last one, we'll do d here. 2x ln x squared plus 1 over x squared plus 1 dx. The concepts we've been working with, or we've been using here, are applicable to linear expressions or log expressions as well. If the derivative of the argument can be seen as the coefficient, then it's fair game. And here we see that this expression can be viewed as 2x over x squared plus 1, and then multiplying ln x squared plus 1. So let's view it in this way. Here we see that if you ever had if you ever had to differentiate ln, you know to say you'd first have to differentiate the argument of the ln, and then you would have to divide it by the argument itself again. So we see that when you differentiate ln of this, you will actually get this whole part here. You can try that. Based on that, we can actually use u substitution here as well. So here, of course, you will let u, being the thing you're differentiating, being the ln itself, ln x squared plus 1. When you differentiate ln, like I mentioned, differentiate the argument, you get 2x divided by the argument itself, which is x squared plus 1. Make dx the subject of the formula. Here you end up having x squared plus 1 over 2x multiplying du. So when you make the substitution now, we'll have the 2x over x squared plus 1. And then where we have ln, we'll have u. Where we have dx, we'll have x squared plus 1 over 2x, then du. We see that the 2x will cancel the 2x, the x squared plus 1 will go with that, leaving us with only the integral of u du. And when we integrate this, we get u to the power 2 over 2 plus c. So just add 1 to the power for u, becomes 2. Then we divide it down as well. But recalling what u is, so this becomes 1 over 2. Where we have u, we'll have ln x squared plus 1, since this was our u. But u has to be squared, so we'll put the square there. Then plus c. So this becomes our solution. Okay, so hope you found this helpful. So if you want to join our online classes, daily online classes in math and the other courses, Triple E and CEE, feel free to reach out in the comment section or to text me on the number 0979 38 38 20 81. Course 26, not like that, that's class 26, like that. So reach out on this number on WhatsApp and we'll add you to the group for online math classes and Triple E and CEE as well. You can reach me via email. Bye guys, see you in the next class.